All right, this video is going to have two main parts. In this video, I want to talk about the difference between a primitive type like int and an object type like string. And we haven't really seen a lot of examples of object types yet, but they will become increasingly important. There's a syntax called dot notation that is used to call a method with an object, and it's a little different than how we've called methods so far. And I want to learn about some of the functionality of string type. In other words, it provides some tools for us to have available to manipulate strings, and I want to show you how they work. So when I talk about a Java primitive, again, int or double, Boolean or char for character, excuse me, they hold a value. All right, so it's sort of like one thing it holds, whatever that type is, an integer or double or so on. An object also holds some kind of data, although it can be more complicated data. For example, a string is a bunch of characters, but also it knows how to perform actions using that stored data. So there's sort of a combination of data and method in one thing. And I'll just briefly say that when we talk about a variable that is of primitive type, we talk about that variable holding the value. When we talk about a variable of object type, that variable holds what's called a reference to the object. In other words, it doesn't hold all the data in that one spot. It basically says here is where the object lives. And we will talk in much more detail about this. But I just want you to start having that in your mind, that variables of object type, like string, are not directly holding those values. So far I've seen something like, let's say we had a method called length of string. So that'd be a public static int, because it's returning some length, and it would have a string parameter, and we could pass it. When we call the method, we would, as an argument, give a string, and it would do some computation on that, somehow count up the number of characters in there, and return a value like 5 for David, right? So this method takes in some data and returns a value based on it. In this object-oriented style, these objects, the string David, we can ask it what its length is, right? It's a little different. Instead of saying, hey, string, go to this method and it's going to do something to you, here we are asking an object to perform some action. Now you can't ask anything you want. It has to be predefined in the code, right? It has to know how to do that. But it's just a slightly different style. And this dot notation is how we talk to objects. So it's the variable name or the object, and then a dot, and then the method name afterwards. And you don't put the spaces here. That's just for me to kind of show that there's something there. Otherwise, you just sort of lose the period. So for example, if we had an object called dog, it's a variable of some animal type or something, and it had a speak method, we would say dog.speak, and that would presumably return a string, or maybe print out something, or send a sound file to someplace. And again, it's a different way of thinking about your programs. I kind of like it in the sense that these objects are there. They almost have a person, they're almost like entities of some kind, and you are asking them to do things for you. And it's sort of a natural way of expressing ideas in programming. And again, it's just something you have to kind of get used to as we learn about this stuff. So objects are a very important, central part of how the Java language is organized. And they help organize sort of our coding tools. In other words, when you have a string, you know what things it can do in sort of one spot, right? There's this string class that defines the string type, and you can look and see all these methods of the kind of things that it does. So our first goal is to start using some of the built-in Java objects. And then as the course progresses, we will start making our own objects. So let's kind of quickly do one thing. So string name equals David. So again, this is a string object type. This is the variable of that type, and we're assigning some initial value, string David, to that variable. And if I were to print out name.length, and actually I want to point out, when I hit the dot here, it shows me like a whole bunch of stuff that it knows how to do. And am I wrong that I don't know? Does length not exist? Oh, okay, it does. I was worried there for a second. So if I run this, it prints out 5 because David is 5 long. So how's this get evaluated? This holds a reference to the David object, and the David object knows about, is a string type, so it knows about length, and it applies it. I can put in something else. This object doesn't have a variable name associated with it, but it's still a string object, and it knows how to apply length to it. So if I run it, well, it happens to be the same length, 5, right? All right, but this dot notation is where you access the functionality of that type. And again, primitives don't have that ability. You can't say int x and then x dot something. It's not an object, so the dot notation only applies to object types. All right, so let's learn a little more about strings. So strings, first of all, are organized as a sequence of characters. A character is just a single letter. And the location of the character is specified by what's called an index number. So anytime you see a string, you should mentally be thinking about what the different positions are of those characters over here in the code. And the other thing to notice is that, hey, look, it starts with index 0. So this causes a lot of confusion for people, right? If I say, give me the first character, to most people that would mean, give me that first one, the D, the capital D. And in computer land, often this index is 0 for it. So there's sort of a difference in terminology between the way we like to speak about these things and the way the computer likes to speak about these things. I think you're better off thinking about the index as how many offsets from the beginning you go, how many jumps you go. So the D is at 0 jumps. It's the first location. You can't avoid it, right? And then the next one, index 1, is we're jumping over 1. Index 2, we're jumping over 2, 3, 4, and well, that's it. So you got to always start counting with 0. And so if I take, index 2, you're going to count 0, 1, 2. It's what we would call the third character. So there's a lot of opportunities for being off by 1 here somewhere. And you'll find in your code, it's relatively simple to make a mistake here and just get the wrong character out of the string. But this concept of an index 0 shows up in a lot of locations, and so basically you'll be forced to adapt to survive, right? So just get used to it now. All right. So there's a bunch of things strings can do. I can pull out these characters one at a time. So for example, I can the second character is, I'm going to go to another line just so it fits. Normally you would want to not break it out like this, but I want to keep it on the screen. So I'm going to say name dot char at character at location. Well, I'm going to say 1 because that's the second character, right? Index 0, then index 1, second character. And if I run this, so name length gives us 5. The second character is the character at index 0, 1, which is the A, and it prints out A. Right? I can change that, right? Index 0, oops, did the wrong one there. Index 0 gives me that capital D. I can pull out, and notice this thing is a character. So letter equals name dot char at, see here it's I would think it's, well, character at 4, for example, and it's what does this evaluate to? It returns a character type, right? So I have to assign it to a character. But if I pull out, I can pull out a portion of the string, and a portion of a string is not a single character, and so it's going to return a string to get the substring. So I can say string part of name equals name dot substring, and I have to say what index it starts at. So I'm going to start at index 1, and then what index it stops at. When I say stops at, it means not including that value. So for example, if I were to hit say 4 here, my expectation is that we would start at A, because that's 0, 1, and then I got to write out 2, 3, 4. I don't quite fit, or tight enough. So if I say start at 1, start at A, include 2, include 3, but stop when you get to the D, because that's 4, then I should get AVI out of here, right? So it starts at 1, includes all the characters up to, but not including this end index here. So let's try it and then talk about it just for a moment. What have I just done? Oops, somehow I get them in. Why is my drawing stuff not... Okay, sorry, I don't know what's going on there. My little drawing tool was confused. So if I run this, oops, there's some problem. I do not have a semicolon there. The little red squiggle should have told me. And I got to print it out too. So just going to copy that and change this to part of name. I run it, AVI comes out. This is useful because sometimes you want to print out like to the end, and then you would just say go to the string.length. And then it goes to the right position. Anyway, we'll play with that more. Okay, strings are immutable. That means they cannot be changed, right? That's sort of a pain. Other languages do let you change strings. But you can assign a new value to a string variable, right? So that the variable can hold different references to objects. It's just the object itself cannot change. So for example, if I have string name equals David, I can't use the character at and assign a new character into it. So I can't poke into the string and modify it. But I can have a name and then assign a new string to it. So you can change essentially the string by maybe tearing it apart using substring and then adding in new information, characters or other parts to it. So instead of just going in and saying, make this letter be something else, you can pull it apart, change, and add it back together with a new value inside it. And we'll be doing that a little bit in the assignment, so you'll see how that works. So sometimes we want to keep adding on to a string and adding more text to it. And where do you begin? So with numbers, for example, if I'm adding up numbers, I would start with a sum equal to 0. That's a starting point that has no value, essentially. I mean, that's not quite true, right? Because it has a value of 0, but it hasn't counted anything yet. You can make an empty string with just quote, quote, right? And so that would start off as a string, and then you could add more information to it. So, for example, let's try to write a method that produces a string that are multiples of 5. So public static, I'm going to return a string. I'm not just printing it out, I'm actually making a string. Multiples of 5. And I'm going to go while we're smaller than some n number. In other words, it's going to be multiples of 5 up to 50 or something like that. And okay, so I want to keep track of what number we're at. We're going to start at 0. That's sort of implicit here. So again, your specification and your comment would have to say something about that. Multiples of 5 starting at 0, going up to, and maybe including n number. I'm going to have a result string that basically we're going to keep adding more to as we loop and find more answers. So we're going to start with nothing. It doesn't, there's no multiples of 5 we've found yet. And I'm going to use a while loop. So while our number is less than or equal to n number. So we're going to start at 0 and keep adding 5 until we hit past n number, and then that will be false, and then we would stop. So let me get the action in first. Hey, here's another form. So we had number equals number plus 5. We saw the plus plus, which adds 1 to number. And then there's a slightly condensed form. If you want to take a number and change it by some amount, this plus equals form does that. And again, it's just nice that you're not writing number twice, right? And it's not because we're lazy, it's because that reduces the chance of errors when you're writing your code. That's the point of it. Not to save you time, it's to save the possibility of making mistakes. So this says add 5. Okay, so we need to take that number and somehow add it to that result string so that we get 0, 5, 10, 15, and so on. So I'm going to say result. I'm going to do plus equals here again. Plus equals number. So this says take the string, take the int number, convert it to a string. It sort of knows how to do this, and then put it back in result. At the end, I'm going to return the string, which is stored in result. So that's the return type there, string, so on. All right, let's. I'm going to do it. I'm going to print it out as I call it. Print line multiples are multiples of 5, multiples of 5, and I want to go up to 25. All right, so let's run this. Okay, so multiples are, well, this is a little hard to interpret, right? Because it found 0, and then it stuck 5 next to it, and it stuck 10 next to it, and then 15 next to it, and 20 next to it, and 25 next to it. So it's like our computation is good, but our formatting's a little bit bad. And so what I can do is I can force a new line to be part of the string, and there is a special character. So in the lab, you guys used, where to go? tap my trackpad. You use // to mean a single slash. And there's also a special character called newline, and it's this \n, and you'll see it in code. But anyway, I can't print line here. Print line also adds a new line, right? But I can't just say print line because I'm not trying to output it here. I'm trying to produce a string. And so instead, I'm going to say put a number, and at the end of the number, add a new line. The next time through, I'm going to add another number and another new line, and so on until I get to the end. And it didn't work. Why is that? This might be. Let me see something. I'm trying to remember. Okay, there was something about the order going on there that messed it up with that plus equals. So let's just skip over that issue for now. So it said multiples are 0, new line, 5, new line, 10, new line, 15, new line, 20, new line, 25, new line actually, at the very end. So I produce the string. So the string that I'm producing is going to look something like, quote, 0, 5, 10, and so on, right? Oops, I didn't manage to. That is kind of what the string looks like if the new lines were to actually force new lines. But if you also looked at the string, it would look like this, and your job is to look at those special characters and understand that that means, hey, it's this /n thing, turn it into, when it prints, something that would be on separate lines. All right, so we're building up this string out of small pieces here to get this larger result. So this is a very common kind of thing, right? You have a starting point, you have a place to hold an answer, and you have a loop that 1 builds up the answer, and 2 progresses the loop forward a little bit. And so you'll definitely want to be looking at this during the homework as a pattern to kind of follow. All right, thank you.